Thank you everybody for joining us today for the continuation of our Locked In Lunch and Learn webinar series. I'm Julia Santagata. I'm one of the Automation System Group Managers here at Rumsey. And today's topic is about successful MicroLogix migrations. And with that, I think I will turn it over to Dave Flores. Dave is one of our automation specialists here at Rumsey. He's been with us for quite a few years. He does cover all of the platforms, but has had a special focus on the smaller control platforms like MicroLogix. So Dave, with that, I will turn it over to you.
Thanks, Julia. Like Julia mentioned, my name is Dave Flores. I'm one of our automation specialists. I've been with Rumsey for it'll be 9 years, June 1st, so coming up pretty soon here. I started as an inside specialist, kind of covering a little bit of everything, and then kind of migrated more towards PLC, HMI products for Allen Bradley. And I'm now our local expert on MicroLogix and the Micro 800 PLCs. I also cover a geographic area of Chester County and Delaware County in PA. This is going to be the agenda for today. When I review migration applications with customers, I look for these three main areas: the documentation of what you currently have, what are the PLC replacement hardware considerations, and can your programming code be converted, and what are the differences there. Some things that I'll mention today are going to be kind of a no-brainer, but I think it's still important to review them. So we'll hop right in here with our first area, which is going to be documentation. Like I mentioned, when I review migration applications, I tend to lean towards answering a lot of these questions before moving forward. Not all of these will apply to your application, and these are more general questions, but they're still important to discuss. And they may vary for your individual project. So the first question here, why do we need to migrate? Is this because your device is going obsolete? Or maybe it's your company's policy to update every X number of years. Whatever the reason, it's still important to know and have that documented and written down. Has your project scope or specifications changed? Are there any important features in your PLC that you must keep when doing a migration, like communications, compatibility with other devices, or specific programming code? Is there a migration guide available? Migration guides are excellent tools for stepping you through a migration process or a migration application. Do you have an updated bill of material and schematics? As these are also very important, especially if you're looking to hire someone to do the migration for you. They'll need to know what and where things are in your cabinet. So keeping that stuff up to date is pretty crucial. Next will be software or programming documentation. Now the first question here is probably the most important. Are you planning on converting the code yourself or rewriting it? If you're planning on converting the code, the following may apply. Do you have a copy of the project file? If not, do you need to upload that project from the PLC? Or can you contact your OEM or owner of the machine to retrieve a copy of the file? Do you have access to the run comments or descriptions? Do you have access to the right software? For the MicroLogix family, that would be RS Micro Starter or Developer, or RS Logix 500. MicroLogix controllers don't save the run comments in the controller, so upon upload, it's just the raw ladder logic. The only way to retrieve the run comments here would be to save them in the original project file and print them out. Within RS Logix 500, you can just create a report that includes both the ladder logic and comments, and I highly recommend doing this, and this is probably something you want to do before you migrate. And then next, for documentation, we have the available tools to help through that process or provide any useful documentation that we already discussed. One of the big ones here is Integrated Architecture Builder, or IAB. This is a very useful tool. I use it almost daily. It can be used to map out an entire control system and network topology. But among the features that IAB has, there's also migration wizards. And these migration wizards will generate the appropriate hardware replacements for your MicroLogix controller based off of your criteria. It's a very powerful tool. There are also project / programming code conversion tools available. There's the MicroLogix to Micro 800 conversion tool, which is available in Connected Components Workbench, and we'll take a look at that a little bit later. This will convert your MicroLogix project to a Micro 800 project. And then there's the RSLogix Project Migrator, which is a tool in Studio 5000 for converting your MicroLogix project to a CompactLogix. And then next we have sample code. This is more or less to help with programming and not so much documentation, but if you're looking to do a specific task with your code, sample code might already have that solution for you, and you can find that on the Rockwell website. And then
David,
last
for the conversion tools, how much can I expect my program to be converted? Is it 100%?
It's not going to be 100%, and we'll kind of get a rule of thumb and take a look at what each will convert it to, but it's mostly going to be around like 85 to 90% of your project. There's always going to be a little bit that you'll have to review at the very least. And then lastly, here we have some migration guides and additional documentation. The ones I have listed here are definitely very helpful. The RM002 publication is kind of a catch-all reference guide for the MicroLogix family migration to Micro 800. This reference guide lists everything from PLC dimensions all the way through wiring and code conversion. If there's a single document that I recommend downloading from today's session, it'll be this one, the RM002. The AP001 application is an excellent reference guide for those who are going from MicroLogix 1500 to a CompactLogix, and we'll take a look at a little bit about what that looks like. And then lastly, we have migration profiles. The 012 profile here is just a quick reference guide for a MicroLogix 1000 application. The 015 is a quick reference guide for the MicroLogix 1500. And lastly, the 034 is a quick reference guide profile for the 1100 and 1200. And these will all be available to download a little later on. I have links later on in the slide here. And then the next area we want to kind of look at is what are going to be our hardware replacements. This is kind of like a gloss overview of the migration options available at a glance. We'll take a closer look at each and which hardware replacements will be the best fit. Most of the MicroLogix lines will have a migration path to Micro 800 using Connected Components Workbench software. To the right, you can see some of the benefits that the Micro 800 offers over the MicroLogix. I won't go down the whole list here, but I'll point out a couple time savers and for when developing and or maintaining a MicroLogix or Micro 800 PLC. There's variable-based addressing, which is very similar to tag-based addressing that you would find in Studio 5000 if you're familiar. There's also user-defined function blocks, which are basically custom instruction sets that you can create, which is similar to the add-on instructions that you would see in Studio 5000 as well. And there's also different programming languages available that offer multiple ways of writing your code to optimize what your application does. Also, I want to mention some gotchas that the Micro 800 series doesn't have. So there's no DH45, DF1, or DNP3 communications available with the with the Micro 800. All these are older network technologies and have been replaced by something different. The DH45 and DF1, if you still need to support these, we do offer some external gateways that can help bridge that gap. And then lastly, Connected Components Workbench, or CCW, is based off of an IEC programming standard, and it's just different than Logix. I'm not going to sugarcoat it for you, but it may look and feel a little bit more similar than you might think. And we'll take a closer look at what that is a little bit later on. Now let's get into our first actual migration by stepping through the MicroLogix family here, and we'll start off with the MicroLogix 1000. This product was discontinued in 2017. If you do currently have one of these in operation, just know that we can't order them anymore, and the recommended path forward is going to be a Micro 800. This is one that I would recommend replacing ASAP, or at least be ready to if anything were to happen to your current controller. The recommended Micro 800 replacement is truly dependent on I/O, like most of these migration options will be, but the MicroLogix 1000 had a varying amount of different bases. The Micro 820 is definitely going to be a great place to start for your migration, but if your application requires more than 12 inputs and 7 outputs, then perhaps a Micro 830 will be more suited. The MicroLogix 1000 also had DH45 and DF1 capabilities. If these are still required for your application, then the recommended path forward will be a MicroLogix 1400. As for migration tools, you can use the converter tool within Connected Components Workbench software, and also the publication RM002 reference guide. This will be extremely helpful as well. And next we have our MicroLogix 1100, which has moved to an active mature product lifecycle state. A final date for this product has not been released yet, but we suspect it'll probably be late 2021 or 2022. However, the MicroLogix 1200 is the latest MicroLogix to receive an end-of-life date of February of 2021, so that's less than a year from now. If you have any of these out in the field, now's the time to start thinking about migrating or stocking up. The recommended hardware replacement for these, again, varies based on I/O, but a general rule of thumb is kind of given here. The MicroLogix 1100 pairs really nicely with the Micro 820 controller. Their I/O counts are very similar, and the Micro 820 comes with onboard Ethernet and serial, so the transition there is pretty close. The MicroLogix 1200 pairs really nicely with the Micro 850. They both have varying bases, but the Micro 850 has a little bit more I/O count available to it and has the added benefit of having Ethernet IP for communications, as well as serial. And again, if your MicroLogix 1100 or 1200 application does need DH45 or DF1, the recommended path there would be to go to a MicroLogix 1400. There's also application code conversion, again, for all the MicroLogix controllers, so that's listed there as well. And then the RM002 reference guide is recommended to take a look at. And then we have the MicroLogix 1400, which is a bit of an oddball here. It's still an active and supported product, and there's no end-of-life date that has been discussed yet. However, it might make sense to migrate your MicroLogix 1400 based on a couple feature sets. So if you're redesigning your application or starting a new project where you would previously look at a MicroLogix 1400, then my recommendation would just be to take a look at the Micro 870. It has more I/O capabilities, it's got more memory, there's a lot more programming options available for you to utilize on your next project. Definitely not a requirement, but just a recommendation. So, and however, if you do require the DH45, DF1, and DMP3 like we've mentioned before, just stick with the MicroLogix. There's nothing wrong with that. And if you are converting to Micro 800 or Micro 870 in this case, the RM002 publication is definitely a good one to have there. And then for the MicroLogix 1500, this was an excellent product when it was around, and it really bridged the gap between two PLC platforms, being the MicroLogix and CompactLogix. Unfortunately, it was discontinued in 2017 and has multiple migration options available based on I/O mainly and feature sets. My rule of thumb for migrating the MicroLogix 1500 application is mainly based on I/O count. So if your MicroLogix application has 2 or fewer 1769 expansion I/O cards, I would look more towards migrating to a Micro 870 controller. And if your 1500 has 3 or more 1769 expansion I/O cards, then look more towards a CompactLogix solution. Now, this is the only migration option in the MicroLogix family that I would also recommend consulting with one of the Rumsey automation specialists. These do tend to be a little bit more involved than the rest of the family, so just be aware. And then again, if you do require those specific communications for DH45 and DF1, MicroLogix 1400 is what you would want to migrate to there. And lastly are some tools. So if you are converting to a CompactLogix and you're using Studio 5000, there's 2 ways that you can convert the program over. One is to save the project as a .acd file itself and load that into Studio 5000. So basically you're saving your MicroLogix 1500 project as a Studio 5000 project. And we'll take a look at that a little bit later. And then the other option is to use the project migration wizard within Studio 5000. And if you're converting to a Micro 870, then the conversion tool for Connected Components Workbench is what you'll use. There's also a specific migration guide for going from a 1500 to a CompactLogix in Studio 5000. If you do end up taking that route, I highly recommend looking through this guide. Very similar to the RM002, but for the 1500 specifically, and going to the Studio 5000 platform. And then lastly, if you've used these gateways-ish devices before in the past, we have a few options here for you. You would typically use these devices or these modules with a MicroLogix 1000, 1200, or 1500 for them to access networks that they otherwise wouldn't be able to. Each of these devices have a replacement from a company called RealTime Automation. They basically have a replica of both of these that you can order through Rumsey. Also, don't worry about the communications too much. Sometimes just a simple PLC conversion might be enough, leaving these modules somewhat obsolete or redundant in your application. For instance, if you had a MicroLogix 1200 and you were using the Net ENI module there, the one on the bottom, to get on the Ethernet, moving to a Micro 850 has built-in Ethernet, so you no longer need that module anyway. And then the last part of today's session, we will focus on the application code conversion. What are some of the differences between RSLogix 500 and MicroLogix hardware and software platforms? What are any tools available, and my personal thoughts and experience using each of them. So when migrating from a MicroLogix to Micro 800 family of controllers, you're going to be using Connected Components Workbench software. This is kind of like a one-size-fits-most for the small standalone applications, and you can use it to program a Micro 800 PLC, PanelView 800 HMI, and also the PowerFlex drives, all in one software. And you can start a CCW project or Connected Components Workbench project with any of the above mentioned devices. So you don't need to start a project with the PLC. You can just have it for your drives or just have it for your HMI if you want. Within CCW, there is a MicroLogix to Micro 800 conversion tool. We'll take a closer look at that in the next slide. And some things to maybe consider is that there are a few programming differences between the two platforms. I won't go over all of them, but I'll just mention some of the common ones that are used, and they're listed here, which would be the PID control, the messaging, the timer, and copy instructions are all a little different than what you would expect in RSLogix 500. Overall, CCW is more feature-rich with programming, and in my opinion has more benefits than the RSLogix 500. The variable-based addressing, the saved comments, additional programming languages, and one of my favorite hidden benefits is the help menu, especially when migrating to the software platform. There's going to be a slight learning curve that's inevitable, and the help menu really helped define some of the instruction sets that you might be struggling with. I also have listed here a Logix theme. So starting in CCW version 11, Rockwell introduced a Logix theme, which basically changes the visibility of the instruction names and the rungs to resemble that more of RSLogix 500. So it's a little easier to adapt the new software after conversion is done. And now we'll take a look at the process for converting a MicroLogix 1200 project to a Micro 850. This was done using RSLogix 500 and a test project that will also be available to download after today's session. Here's a rather simple MicroLogix project using just internal bits, some physical I/O, and a timer instruction. Again, it's very simple, but it was just for a test project. So while we're in RSLogix 500, we want to go to File and then Save As, and we want to save our project as a .slc file instead of the typical .rss. We also want to select the Export Database checkbox. This will allow for the file comments and run comments to be converted. And if you click on the Export Option button, just make sure everything here is checked. But the one we do kind of want to highlight here is the .eas file up there at the top. This one up here. And that's the one you need for your comments to be saved. And then we're going to go into Connected Components Workbench, and we're going to open up Tools and then the MicroLogix Library Converter. Why it's called that, I have no idea, but that's what we're going to use. And then we'll do a few things here. We're going to browse for that .slc file we just saved in our RSLogix 500, and we'll also select that .eas file, which was created when exporting the database that we just did in the previous step. From here, we're going to select from a variety of Micro 800 controllers. In this case, it's just going to be a Micro 850. And then finally, we want to make sure that concatenate checkbox is checked down there at the bottom, and hit OK. This checkbox will put our bit descriptions in the proper location, and we'll take a look at that after the conversion. And then we'll just hit OK, and it'll convert the code. And this is what it looks like within Connected Components Workbench. And the final step here is just going to be to review. So this is what it will look like in CCW, and we'll notice a few things here. The physical I/O points are a little different from what you would expect in RSLogix 500, so we'll review those real quick. If you notice on the first rung, there's the _IM_EM name there, and this basically stands for it's an I/O, it's embedded, it's a digital input, and it's position 0. And then if you noticed on the second rung, there's a timer instruction, which looks a little different. And this is actually what's called a user-defined function block or custom instruction. And it was created when we did the conversion. So this was hands-off on our part. Since the IEC code that CCW uses, and it differs slightly from RSLogix 500, there's not a direct translation, so Rockwell actually provides a conversion instruction for you that might look a little bit more familiar. So you can take a look at the actual code itself over there on the left-hand side under the project organizer. I have it highlighted if you want to see how that instruction was created. And then lastly, we'll take a look at the global variables. And we'll just notice a few things to note here. We'll notice that the B3 variable, which is our internal bits for MicroLogix 500, they're listed as an integer and not as a Boolean here. My guess is that this is probably the streamlined way when doing the conversion. However, when you're referencing the internal bits as shown in the ladder logic, the concatenation of the variables are listed right under the comment section and highlighted here. You can see that B3:0/0 is the run command, and then B3:0/1 is the start bit, but they're laid out in a little bit differently than what I would expect, and they're just concatenated onto one comment instead of broken out into each individual tag or variable in this case. And this is just something to note. I don't know if they're going to end up doing some more conversion options where it breaks it out into their own comment section, but this is just what we have. And also note that there is a limit to the number of characters that can be on a comment section, so the results for these may vary based off of your application. And just as kind of like an FYI, I do want to mention that you can put a CCW project and RSLogix 500 project side by side, two applications side by side, and copy and paste the actual ladder logic from one to the other, and that works just fine. But I do find that using the conversion tool is a little bit more smoother and efficient, and would be my recommendation for doing the program conversion. But other than that, that's basically using the conversion tool. And the time it took me to basically recite this process is how fast that program can be converted. It's a very smooth and very quick. We also have no conversion errors or flags, so this could be good to download to a Micro 850 and just start running. And then kind of on the flip side of that, since there's two programming software that the RSLogix 500 can migrate to, we're going to take a look at the Studio 5000 conversions. So when migrating to a compact Logix controller, you'll be using Studio 5000 Logix Designer software. Studio 5000 is a software suite just like CCW and houses different applications based off of what you need to program, including Logix Designer, which you can use to program a compact Logix or ControlLogix PLC or PowerFlex drives. And then there's the View Designer software, which is included with Studio. You can use that for the PanelView 5000 HMIs. There are two conversion options available for migrating to Studio 5000. We kind of touched upon these earlier. One being the migrator tool, which is going to be very similar to the one we see with Connected Components Workbench, and it just varies slightly. And then the second way is to save your MicroLogix project as a .acd file, which is the same file structure as the Logix Designer application. So this requires a lot less steps to convert, and does it in kind of the same manner as the migrator tool as well. So we'll take a quick look at what that might look like in the next slide. And then similar to CCW, there's going to be a slight learning curve when going to Studio 5000. Again, you're going to be moving away from a file-based addressing to more of a tag or variable-based with aliasing. So this is a little bit different. And there's going to be some additional features that Studio 5000 has, such as add-on profiles, which allow you to configure I/O modules within Studio 5000 that aren't necessarily limited to Rockwell. So third-party vendors will have their own customized profile that you can use within the Studio 5000 software. So and plus there's a huge variety of instructions and features available to you. For the most part, the instructions function more similar to RSLogix 500 than they do to Connected Components Workbench, but these are only slight differences, and just be aware that there might be a little learning curve there. The help menu for Studio 5000 is excellent as well, so if you do get stuck on an instruction conversion, take a look at the help menu, and that'll definitely help out in some way. The benefits here are basically a no-brainer, but I do want to mention one thing though. Since the migration into Studio 5000 will more likely be from a MicroLogix 1500 than any other in that platform, you can reuse the existing 1769 I/O modules that the MicroLogix 1500 has access to. So this is going to be a huge time saver for wiring, installation, and programming. And we'll take a look now at doing a migration from our RSLogix 500 to Studio 5000 by just saving the file. This will convert the project to a CompactLogix PLC from a MicroLogix 1500. This project is very similar to the previous example, except I've just changed the PLC to a 1500 and added 1769 input module, so we can kind of see some of the differences here. Now I'm going to start the conversion similar to the previous example by first going to the Save As option, and then under the Save As type, select the Logic Designer file .acd, and then click Save. And this will bring up a short window, or a short wizard, that starts by asking what PLC do you want to convert to. In this case, we're just going to select the CompactLogix L24ER, as indicated here. And then now we have two options for migrating our expansion I/O. One is going to be keeping our existing I/O. The other is updating all of the I/O into something else and putting a placeholder in place. And I found that there's differences when using each of these. And the conversion tool wants you to place the I/O in a remote rack most of the time. And often that might not be the case. That might not be what you want to do, and it will require a lot of reprogramming and extra steps in the long run. So my recommendation here would just be to update the existing I/O and then create a placeholder tag. This will not create any I/O modules for you, but they will be easily added in and you can alias them accordingly. And if you do have different modules, these options may look a little bit different. But after we do the conversion, we can see the ladder logic here. The placeholder tags were created as indicated, but if you notice on the I/O tree, there is no local I/O modules. So you'll have to create them. One more thing I would like to check though is the controller tags themselves, like we did with the Connected Components Workbench. And it does seem like it imported in a very similar manner than the Connected Components Workbench conversion tool. But notice one major difference is the B3 tags, and this is kind of what I was alluding to earlier, is that the B3 tags here are broken out. Each have their own description comment displayed, and this is a little bit different on how Connected Components Workbench handles the conversion here, and it just concatenates all of those descriptions into one variable. So this is just something to be aware of when doing the migrations here. And kind of to wrap things up, with both of these methods for CCW and Studio 5000 that we looked at today. And I mentioned earlier that each method will convert roughly about 85 to 90% of your project. There's always going to be a recommendation to review the code afterwards, just make sure everything is where you want. There will be a log file that is created with each of these, and also it'll flag anything that may not, or that will need attention. So just be aware of those when you're doing the migration or code conversion. And then lastly, to finish up today's slides, I just want to do a quick recap. When preparing for your migration, these three areas are crucial to have a smooth PLC conversion. The first area here is documentation, and whether you're doing the conversion yourself or hiring somebody to do it for you, preparing the right documentation is definitely going to be key. For generating hardware replacements, being the next area, knowing what are the recommended hardware replacements and will they suit your application needs. And then lastly is the code conversion, and the important question there again is, are you rewriting or converting the code? And we took a look at two different conversion tool examples today. We looked at the example with Connected Components Workbench and also Studio 5000, and a little bit of the differences of both. So if you do sit down and review these three areas prior to a migration, you'll have a smoother conversion with your MicroLogix projects. And then we reviewed a lot in kind of a short period today. So don't worry if you missed anything. The recording for today's session will be available soon using the same link as the registration page, I believe. Julia can help me with that one. And here are a few useful links for publications and the recording. Project files, examples, like I mentioned earlier, will also be available to download if you just want to try it out yourself there.
Dave, that's correct. Using the same link as the registration, it'll now say, starting tomorrow, it'll say watch the session, and then it'll also be on the Rumsey YouTube channel.
Awesome, thank you. And then thanks for tuning in today. If you guys do have any questions on today's topic, please contact your Rumsey rep or any member of the automation team. Also, don't forget the specialist team will be hosting these tech talks every Tuesday and Thursday through the end of May. The link above takes you to the full schedule, so please join us again soon.